t times dt over dx, but we have dx over dt, meaning dt over dx is the reciprocal of dx over dt, isn't it? The parametric equation of an ellipse is given by x 5 cos t and y 3 sin t, where t is the parameter. Show that the Cartesian form of the equation is x squared over 24 plus y squared over 9 is equals to 1. Then differentiate with respect to x, giving your answer in t only. Now, if you start with the first part of this is just a case of the Pythagorean identity, isn't it? So Pythagorean identity, you know, when you have cos squared t plus sin squared t is equals to 1. So if you're given x is equals to 5 cos t, it simply means that x over 5 is equals to cos t, isn't it? So if you square both sides of the equation, it will imply that x squared over 25 is cos squared t. Again, you've been told y is equals to 3 sin t. You see that? If you divide both sides by 3, you get y over 3 is equal to sin t, isn't it? So if you square both sides of the equation, we are squaring both sides of the equation because we need the Pythagorean identity, isn't it? So if you square both sides of the equation, it implies that y squared over 9 is equals to sin squared t. Then we go back to the Pythagorean identity. Cos squared t plus sin squared t is 1, but cos squared t is x over 25, then plus sin squared t is y squared over 9 is equal to 1. And you've dealt with the first part of that equation, just like that, isn't it? We do there. You just look for the Pythagorean identity. Because this is a conic. This is a conic, and a conic which is in this form is what? It's a circle, isn't it? A conic which is in this form is a circle, isn't it? Are we together? Yeah. Because you can remember, x was r cos t, y was r sin t when you are deriving, isn't it? That is a parametric equations of a circle. So you get with that. You go to the second part. So the second part you've been told to differentiate with respect to x. Leaving your answer in t only. So that is very simple. What you do here is this. For you to differentiate with respect to x, this is what you do. I hope you are done with this.
Yes, I am.
So deal with this, then we differentiate with respect to x. So you start. First parametric equation here is x is equals to 5 cos t, isn't it? So we want to differentiate x with respect to. We've been told to differentiate with respect to what? To x. Are we together? So if you want to differentiate with respect to x, what you do, you introduce dx on both sides of the equation, meaning you are differentiating with respect to x. Are you seeing that? Are we together?
Yes.
So if you differentiate x, you get 1. Are we together?
Yes.
Because it is x raised to power 1. Now you differentiate our polynomial. See, 1 times 1 is 1, then you reduce the power by 1.
Yes.
See, now you get x raised to power 0. Anything raised to power 0 is 1. 1. So you get 1. Then which derivative do you remain with? You differentiated x with respect to x, meaning you remain with dx over dx. Is equals to, then here 5 is a constant. You factorize for constant outside, isn't it? So if you factorize constant outside, it means you are differentiating cos t. If you differentiate cos t, you get negative sin t. Remember the inner function is just t. Differentiating t is 1, isn't it? So the outer function is cos, meaning cos t means there's something inside. So what is outside just cos? If you differentiate cos, you get negative sign of what is inside, isn't it? Yeah. Then you differentiate the a, which is t. If you differentiate t, you get 1. Then after the end of differentiation, which derivative are you remaining? You are differentiating t with respect to x. So you remain with dt over dx. Are we together there? So the x over the x is 1, meaning this one disappears, isn't it?
Yes.
So can you now see? If you bring this one this side of the equation, what do you have? You have dx over dt to be equal to negative 5 sine t, because it is like you are multiplying both sides by dx over dt, to get rid of dt over dx, isn't it?
Yes.
Are we together there? So it means that we have dx over dt is negative 5 sine t. So the first thing we found, dx over dt is negative 5 sine t. Let us go to the second parameter. The second parameter there will be given y is equal to 3 sine, and we will go to differentiate with respect to x, isn't it? Meaning we introduce ddx on both sides of that. We introduce dx on both sides of the equation. So if you differentiate y, you get 1. Because it is y raised to power 1, coefficient is 1. So 1 times 1 is 1, you reduce the power by 1, isn't it? Y raised to power 0, anything raised to power 0 is 1. So it means when you differentiate y here, you get 1. Then which derivative you remain with? dy over d, because you are differentiating y with respect to x. Are we together? The variable you are differentiating is y, and it is with respect to an x variable. So it is dy over dx. The independent variable is the denominator, isn't it? To be equal to 3 is a constant you factor out. If you differentiate sine t, remember the sign, there's something inside. So out the function is sine, isn't it? If you differentiate sine, you get cos, isn't it?
Yes.
So you get cos of what is inside, meaning you get cos t. If you differentiate sine t, then the inner function is t. If you differentiate t, you get 1. So it is 1 times cos t is just cos t, isn't it?
Yes.
So which derivative do you remain with? The last thing you differentiated is t, isn't it? Meaning you differentiated t with respect to x. So you remain with the dt over dx. Are you seeing that? You remain with the dt over dx. So you can now see dy over dx is equal to 3 cos t dt over dx, isn't it? Are you there? So look here. You were told to leave your answer in t only, isn't it? So look here. What do we have? We want dy over dx. Meaning we get rid of dt over dx. So what is dy over dx? Dy over dx, which is the derivative, isn't it? The derivative is always dy over. It is 3 cos t times dt over dx. But we have dx over dt, meaning dt over dx is the reciprocal of dx over dt, isn't it? Are you seeing that?
Yes.
See, this one is 3 cos t times dt over dx. But what is dt over dx? The dt over dx is the reciprocal of dx over dt.
Yes.
So what is the reciprocal of that? It is 1 over negative 5 sine t. Are you seeing? Are we together? So are you now seeing the derivative dy over dx? The derivative dy over dx is now what? We have in the numerator, we have 3 cos t times 1 is 3 cos t, isn't it? In the numerator, we have 1 times negative 5. Negative 5 sine t. So if you simplify that, you get 3 over negative 5 is negative 3 over 5, isn't it?
Yes.
Then cos t over sine t is the reciprocal of tan t, isn't it? Tan is sin over cos. You see? But now cos over sin is cot t. So you found the derivative dy over dx. The derivative dy over dx is negative 3 over 5 cot t, meaning you left your answer in t only. There is no x on the other side of the equation. You see? You differentiated with respect to x. What are you differentiating with respect to x? Because your equation is having only 2 variables, x and y. So if you are differentiating with respect to x, meaning it is dy over dx. Are you seeing that? So dy over dx is having in terms of t only. Are you fair?
Yes.
And you are done with that kind of problem. So that is a case of an implicit differentiation, which deals with differentiation of parametric equations and implicit differentiation